The knee-jerk reflex, which is also known as the patellar reflex, is a simple reflex pathway that plays a crucial role in maintaining posture and balance. It involves the contraction of the quadriceps muscle, located here, in response to the stretching of the patellar tendon. Remarkably, this reflex pathway only occurs at the level of the spinal cord without the direct involvement of the brain. Instead, the brain receives information only about the movement after it has been initiated. So many of us may have been familiar with the knee-jerk reflex test, where the doctor taps the patellar tendon just below the kneecap with a small hammer called the reflex hammer. This tapping then leads to an automatic outward kick of the lower leg, and deviations from the expected reflex response can indicate disorders or nervous system damage. Understanding the neural mechanisms underlying this is essential for diagnosis and comprehending such conditions. So now delving more into the topic, the process starts when the patellar tendon is tapped and is considered a stimulus where the muscle is stretched. This stretching activates the intrafusal fibers within the muscle spindles, which are specialized sensory receptors that detect changes in muscle length. The information or sensory information from the muscle spindles is then transmitted through sensory nerve fibers known as the spindle afferents to the spinal cord. Spinal integration now occurs, which is the process where the sensory information is integrated in the spinal cord and directly synapses with motor neurons that innervates the quadriceps muscles. This direct synapse is known as the monosynaptic stretch, which results in the rapid contraction of the quadriceps muscle, specifically the semitendinosus muscle. Reciprocal inhibition refers to the simultaneous relaxation or inhibition of the antagonist muscle group, and in this case, the hamstring semitendinosus muscle, colored in purple here, to allow the quadriceps muscles to contract more effectively. This reciprocal inhibition, if you follow this pathway here, is mediated through inhibitory interneurons in the spinal cord, this very little neuron colored in pink here, ensuring coordinated muscle activity during this reflex. So you might be wondering why monosynaptic reflex is called that way. This is because the knee-jerk reflex involves direct connections between sensory neurons and motor neurons without any neurons in between. Although the reflex is often simplified in diagrams, as we've shown here, to only show one sensory and one or two motor neurons, in reality it involves many neurons. Stretching the quadriceps muscle alone activates several hundred sensory neurons, each of which makes contact with around 50 motor neurons. Additionally, the sensory neurons traveling from the muscle spindles stimulate interneurons that inhibit the activity of motor neurons that supply opposing muscles like the hamstring muscle. The stimulation of these inhibitory interneurons causes the actions of the quadriceps muscles to be unopposed.